Building contractor charges 18,000 per metre squared plus an administration fee of 22,000. Now, what that means is if he turns up and does nothing at all, you're still going to pay 22,000. Right? So now I'm saying to myself, okay, per metre squared area. So I'm going to say area times by 18,000, or 1,800 rather, plus 22,000 is the piece of maths I'm looking at. So the floor area is going to be normally distributed with a mean of, so the area has a mean of 136 and a sigma of 15. Okay, hopefully that's making sense. Right, calculate the probability that a particular project costs more than 275,000. Okay, so in order to do that, we're going to assume that the cost of the project is also normally distributed, which we know it is. Okay, and the mean of the project cost is what I've got to work out. Okay, I've also got to work out the sigma for the project cost. Okay, and as long as I can work out the sigma and the mean, I'll be all right. So, if the mean is 136, then the mean of the project cost, so I'm going to say now that equals the cost of the project, is going to be simply 136 times by 1,800 plus 22,000 is the mean cost. Okay, and hopefully that makes sense. Right, now if sigma is 15, then the variance is 225. Okay, how? Because the variance is the squared of that. 15 squared is 225. Okay, now we know from our formula sheety thingy that we talked about yesterday that the variance of NA is n squared times by the variance of A. Okay, and hopefully you remember that. Is that okay? Right, I'm talking to you mainly. Okay, so what we end up with is that the new variance is going to be 225 times by 1,800 squared.
How can we square the 1,800 instead of 225?
Right, well, technically what I should have done is square the 15, but I've already done that bit.
Oh.
So if you want another way to look at it, what I'm doing is 15 times by 1,800 squared. That's another way to look at it.
Okay.
Alright, but what I've done is it's n squared times the variance, and the variance is 225, which is already squared 15. Okay? So I'm hoping that makes sense. Now, so 15 times by 1,800. I don't have a calculator, may I? Thank you so much. Okay? I'm good, but not that good. So 15 times by 1,800, and don't forget to do it squared. Oh, no, done that wrong. That's not 15, is it? It's 225. That was on my original. Okay, and so that is 729,000,000. Okay, now remember that that's the variance. Good. So therefore, to get the sigma, I have to square root that. So that's what I'm going to do. Square root the answer. Oh, not pi. So sigma is 27000. Okay. Now we haven't done this bit yet for the mean cost. Okay. So that's 136 times by 1,800. Oops. Plus equals plus 2200. So your mean cost is going to be 266800. Okay, so now what I've got, according to my question, I've done all of that because I can't do this without that mean and that standard deviation. I now know that the mean is 266800. I know that the sigma is 27000. Okay, and the question says calculate the probability that a particular project costs more than 275. So that's 266. So 275 is there. And I want more, so I want all of that. And so now I can have my calculator. I've got my sigma, I've got my mean, I've got my lower value, my upper value is going to be all those 9s. Okay, so that's what I'm going to do. So I go to menu, I go to stats, I go to distributions, I go to normal, I go to cumulative. My lower value was 275,000. My upper value is every 9 I can put in. My sigma is 27000, and my mean was 266800. And my answer is 0.38067. Now this was just like a normal distribution question. It was dead easy. The problem is that you had to work out the mean and the standard deviation, and that's what took us ages.
Yeah.
Okay? There you go.
Okay.